All right, guys. So on page 19, you're in our title at 1B.1, function notation. So on page 19, this is going to be a review, hopefully. And we're going over reading and evaluating function notation. Does anyone remember what function notation is? How do you write out the function? It's how you write out a function. It's just another way of writing it, right? So you don't have to write all this down. Using function notation. So when we're using function notation, we usually have variables y and x, right? And so your x is your independent variable, your y is your dependent variable. And all you're doing is basically using f of x instead of y. That's all function notation is saying, is that instead of using f of x, you're now going to use y. That's all that means. Or not, I didn't want you to highlight anyway. There we go. And you read it as f of x. That's all function notation is. All right. For function notation, it doesn't always have to be f. It could be g. It could be h. It could be t. It could be a. When we were doing our, what do you call that thing? Exponential. Remember our interest? It was a, right? It was our amount at the end, our a of x. It could be anything. And that's what it's called function notation. Okay. I call function notation the fancy y. All my y did was get dressed up a little bit, right? And put on a suit and tie and say, here I am. All right. So if you need an example to remember what function notation looks like, here it is. So if I start off as y equals negative 3x plus 2, then my function notation is simply f of x equals negative 3x plus 2. Okay. So the important stuff is highlighted in yellow because we all should remember that x is our independent variable and y is our dependent variable. So I didn't feel like that's something that we need to write down. But we do need, just reiterating that the most commonly used letters are F, G, and H for function notation. And it's not multiplication. It's read as F of X. That's one of the biggest misconceptions is that people think that they're multiplying F times X. And I'm like, what is your F? What are you multiplying? It's amazing to see people's work. And I'm like, oh, cool. All right. Okay. Questions about reviewing function notation so far? Okay. So that's how we read in function notation. Again, remember, it is a symbol. It's a special symbol. It does not mean you are multiplying. It is not F times X. Okay. All right. So when we want to evaluate a function at a particular value of X, all we're doing is substituting that value in. Function notation is a good way that models substitution. Okay. So for example, this was supposed to come in like an auto thingy, like where you didn't see it all at once. My animations are rough. Okay. So for the previous example, if we had f of 2, right? That means that I'm going to substitute 2 in for my x, correct? So as long as once I see f of 2, I'm substituting in for my x. So looking at our given problem here, we have f of x equals, so you're writing this down, negative 3x plus 2. Okay. If I'm looking for f of 2, that means everywhere there's an x, I'm substituting in the 2. So I substitute in the 2, I evaluate, and I get my answer. So there's two ways of writing it. You can write when x equals 2, then f of x equals negative 4. You can write it as an ordered pair, and you also can just shorthand writing it as f of 2 equals negative 4, right? Using function notation seems pretty quick, easy, correct? No one's like, where are you getting this from, man? Remember, if you can't see or whatever, the notes are always posting. You can follow along on your Canvas for people who are ashamed to wear glasses. Or someone's head's in your way. I get that part too. All right, cool. So evaluating function notation simply means we're doing what? What's the conclusion? Substituting. That's our main thing, is that when you are evaluating with function notation, keyword substitute, substitute, substitute. Okay. I am substituting in this value for X. Okay. All you need to remember, it's my independent variable value. All right, here's your example. So I would like for you to write down g of x equals x squared minus 2x. And I would like for you to find g of -3. 90 seconds on the clock. So you have g of x equals x squared minus 2x. And you're going to look for g of -3. As you have your answer, check with your group members to see if they have the same thing. Okay. Let's see how we did. What did we get? I got a 15. Anyone got anything else different? All right. And all again, it just means substitute. Wherever there's an X, it becomes a -3. Remember, a negative times a negative is a positive. So that -3 squared a 9.
How much time I got?
30 seconds.
Look at it.
30 seconds.
All here.
So I don't get $5. A year later. Look at God.
The doors are locked. There you go, Miss Jones.
Thank you, sir. Thank you. Whole year of Skittles, guys.
You know, I haven't been at this school the whole year.
You've been in and out. All right, so we're good? Really quick. So again, you can write it in various ways. You can just simply say this is what it equals. And you can write it as g of -3 is 14, or you can write it as a ordered pair. Okay, as an ordered pair, am I out? In the bottom of that file cabinet? The one by the Baylor Bear flat towel? On the wall, straight ahead. This way, no, where I'm pointing, George. And the very bottom back of the file cabinet. There should be more. All right. Okay. So here we go. Just doing a quick check again. So now you have -x squared plus 3x plus 4. And now I'd like for you to take 2 minutes to find the following 4. You're going to find f of -1, f of 0, f of 2, and then f of 2a. All right, go. Okay, so on the first one, we had f of -1. And so we're substituting. Remember, function notation is just telling us, hey, please plug in. We're going to be friends. So this is going to become, I need a negative in front. All right, -1 squared plus 3 times -1 plus 4. How did our setup go? Yeah, everyone's good. Remember, a negative times a negative is a positive, but then there's a negative waiting for it. So it makes it a negative. So we have -1 minus 3 plus 4. What'd you get? -1 minus 3. If you owe me $1, then you now owe me $3. You owe me $4. And -4 plus 4 is 0. All right, so then we have negative, and then we have 0 squared plus 3 times 0 plus 4. That's going to give us 0 plus 0 plus 4. I really wanted you guys to challenge yourselves and do it without a calculator. So I gave you easy numbers, low risk situation. A lot of mistakes happen when we're overly confident and reliant on the calculator, okay? Last, we're plugging it, well, second to last, plugging in 2, negative, and we have 2 squared plus 3 times 2 plus 4. That's going to give us negative 4 plus 6 plus 4, which is just 6. It's just 6. Okay. Now, when you got to D, could you plug that in a calculator? No, you could not. This is, again, why we don't want to become too dependent on calculators, because when there's variables in play, those calculators can't help you. Okay, so you have 2x squared, which is 4x squared, because 2 squared is 4. X squared is x squared. So we're left with negative 4x squared. 3 times 2 is 6 plus 4. All right, so looking what we have, for f of negative 1, that equaled 0. For f of 0, that equaled 4. For f of 2, that equaled 6. And for f of 2x, that equaled negative 4x squared plus 6x plus 4. And that's because I don't have a value for x, so all I can do is plug in and simplify. Okay? If you made any hiccups or mistakes, do you see where they are? Yeah? Okay. Again, we don't want to become too calculator dependent. The calculator is a great source and tool, but it can't be your end all and be all. Okay. Because you're human, and if you type the wrong thing in the calculator, that's the wrong answer. Okay. All right. Questions, comments, concerns. Okay, we're gonna be doing a problem trail. So how this is gonna work is the problems are out in the hall. I'm gonna number you guys off.